Welcome to today's webinar. The topic today is 5 most important advantages of digital wind tunnel for engineers and architects. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, customer projects, newsletters, and so on. I will be the moderator today and also the presenter. My colleague Clemens Gutmann will support me. He will answer your questions during the webinar. Clemens works in our customer support team and also in the product engineering team. He's, for example, responsible for the add-on form finding and the standalone program RWIND. Okay, then I say some words how you can ask questions. At first, I switch off my webcam that you can see the full screen. Just press the button with the question mark here above. Then enter your question in that field, press send, and Clemens will receive your question and he will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. So, to the agenda today. At first, I will introduce you advantages of the CFD simulation over wind tunnel testing. Then I show you some examples and I turn in the third point to Rfem 6 and RWIND 3 and do their wind simulations and explain advantages and so on. Okay, to the first point, advantages. CFD is the computational fluid dynamics simulation. It's often more cost effective than a wind tunnel test. Imagine you have got to determine the wind effects of such a city. It's quite easy to draw that in a CAD program. But if you create physical models of that, it would be more cost intensive in the wind tunnel test. And that's also the next point. You have to prepare models and so on, have a lot of work in such a wind tunnel test. You have to invest in a CFD software. At least if you buy, for example, RWIND, there are also free tools, but it's not so easy to handle. They are not so easy to handle. But you need no further material costs. And you can do that with or use the software for many simulations. And there are fewer resources required for analysis of individual variants. I did that also in the preparing phase for the webinar. I calculated different models simultaneously with a cloud calculation. And that's possible with the digital wind tunnel. Then the first or the second main point are the simulation options. You can visualize the flow and pressure. That's the flow in the picture here. You can consider complex geometries and high wind speeds. Imagine you have to create a physical model of a complex geometry. That's quite more difficult when you have to build the model and not only to draw the model and use it for the digital wind tunnel. And that's that point, fewer physical restrictions than the wind tunnels. Now you have to for example, for a high-rise building, you can only create a model for the wind tunnel with lower or smaller dimensions. But in the digital wind tunnel, you can build or draw the high-rise and consider the higher wind pressure in higher floors, for example. Wind tunnel tests are limited to data from specific measuring points. In the CFD analysis, you can select more than few points, as much as you want. We do that also later in the program, and can detect the values on the certain points. Then there are also different options. You can consider terrain surfaces and neighboring objects. We will do that also later in the program. So next point is flexibility, or next advantage is flexibility and time efficiency. You can adjust the parameters quickly, for example, wind speed, density, and more factors. So then simulations can be carried out and changed quickly without the need for modifications to the physical structures. You can move a structure in the digital wind tunnel, or modify. That's quite easy, or easier than when you have to modify the physical model. And the next one is performing multiple scenarios in a short time frame. That's and also in parallel. That's what I mentioned before. Then accessibility. Advances in software development and cloud computing have made CFD accessible to a wider audience. For example, OpenFOAM is a free tool. We use it also for our simulations, and you can do the CFD simulation in a virtual environment. It's free, but not so easy to handle as our wind. But there's a free access. And for structural engineers and architects, my eyes, the most important point is the integration in modern technologies. You can couple the wind analysis and the structural analysis, and you can do that with the coupling of our wind and with our Rfem and RStab. Okay, then areas of application, facets and building. You can investigate the pedestrian comfort and safety. You can use it for urban wind flow optimizations. You can optimize building shapes, renewable energy structures, as you can see in the model on the right side. You can detect vortex shedding. For example, you can see that in that picture. Because of vortex shedding can occur vibrations. That's quite important. You can use the CFD analysis for topography studies or wind shielding. Maybe a point for architects. You can planting, for example, trees to direct the wind, or save because of higher wind pressure and so on. Then you can do wind flow simulations for ships, trains, cars, etc. Okay, then I show you some examples that we already published on our website. When you have downloaded the slides here, you can click on the links for more information. You can download the PowerPoint slides from the same page where you can find the recording and the models. On the next days, you will get an email with a link to that page. Yeah, the first example is the Czech Pavilion for the Expo 2025 in Osaka, Japan. Yeah, it's from A2 Timber, and you can see that on our website. It's not a regular building. You won't find wind pressure values in the standard. That's a typical use for the digital wind tunnel. So then the Wang toll station in China. It's also a membrane and steel structure, and you won't find any value in a standard for the wind pressure and wind suction. Pristina city center in the Republic of Kosovo was also used, or also the wind tunnel or wind have been used for this customer project. You can also see where are the neighbor buildings are considered. So then Semiramis, Hanging Gardens of Zug in Switzerland. That's not a building, but a sculpture. Also a typical application for a wind tunnel that we use in our wind. Then the Amphitheater Benedict in Most, Czech Republic, also a membrane or a steel membrane structure with a building behind the structure. And there was also our wind used. Then a project from the United States, container structure, also our wind, and of course Rfem was used for the structural design. Then residential buildings in Trieste, Italy. It's an area of high wind values, and the customer used or determined the values on the facade, also in our wind. Then a project in Argentina, that building in front of a stadium. You will also find or won't find any values in a standard for the wind pressure and wind suction. Okay, that was all to the application examples. Now we turn to the program. I start in Rfem 6. You can see that steel membrane structures with cables here. It's the same structure, and I would like to consider not a flat terrain for one structure, and we would like to compare the results. You can see pre-stress is already defined for the membrane structure. Okay, then we turn to the base data. At first, we activate the wind simulation here. And I have already considered the model parameters. I think a lot of you knows how to do that. You can use the values on our website. I prepared that already previously. Okay. So then I have to import a terrain, an IFC file, turn to File, import IFC. I prepared it already. So, okay. Okay. So, and you can imagine that we get higher values for the wind pressure and suction on this side. You can see where is a lower terrain here. So, but we have to do some settings. I turn above here to mesh settings, wind simulation. The IFC model is already detected. If not, you can do that manually. So, for example, okay. So, and you can run RWIND in a silent mode or not. That's the default setting. We want to open RWIND when we start the calculation. That's why we leave this setting. Okay, then we create a new load case. Above, I covered wind. So, and we use or switch to the analysis type wind simulation. Then action category should be wind. So, and we have to consider the initial state from load case 1, pre-stress. So then wind simulation, according to standard, Eurocode 1. That's all. Wind tunnel, we leave the settings. Okay. So now we could start the calculation. That would take some minutes. We skipped it. I jump in a already in our wind calculated model. So you can see it here. That's the streamlines. We can modify the visibility, but at first we take a look at the surface pressure. And you can see there are higher values for the suction. We can change the pressure values. It's now at the moment kilopascal. So we change it here under options, unit, pressure. There should be the same values, but in our unit. Okay, so and let's create point probes. New probe. Set graphically, for example, here and here and here and here. Okay. You can see there are higher values, and that's the suction. And when you turn the model, you can see the value is changed for, also now pressure is displayed. And it's interesting, you can see higher values because of the lower terrain here. So let's turn to the streamlines. You can also do a flow animation. And as I already said, we would like to modify the display of the streamlines. Okay, at first I edit a reduced domain. So I move it a little bit in this direction. Apply. So, and then I modify the simulation parameters. No, it was not the right button. Streamline settings here. Okay, and now I can drag and drop that here. The quarter is now larger. Okay. So now we can start the flow animation again. And you can see that quite good that there are higher wind flow is on the right model. We can stop it again. We can also change the control points, or more points, and more streamlines. Okay, well, as you can see, you have a lot of options to investigate the wind flow in RWIND. So we turn back to Rfem 6. So that's also the calculated model. And what interesting is for us, this is not only that parameters, for example, the pressure and the streamlines. But you can also show that in RWIND. More interesting it is what happens with the structure. For example, when I set here the support or select the support reactions, I go to the navigator results, result reactions, nodal supports, and I switch or check PZ, and I change the direction, in X direction. And you can, for example, compare these values, 146, and it's much higher on the right side with the lower terrain, 156, and also you can compare these results for the 84 and 78. It's much lower here with a flat terrain. And it means that it's important that you consider such terrains or neighbor objects. If you have such surroundings around your structure. Okay, then we turn to the next model. It's a three-sided billboard. And I would like to show you how you can create 4 wind load cases for 4 different directions easily. Just do that with Insert, Load Wizards, wind simulation dialog box. So, and you can enter here an angle, 90 degrees. Start angle is 0, and the end angle is 360. And you will see there are 4 load cases now. So go to the settings. Okay. Wind simulation. All is good. Okay. So then we turn to the calculated model. You can see the wind tunnel, and I would like to show you the results. Also the support reactions. $171 for that load case. It's the moment, yeah. Then 222, and so on. 288, and you can see that it is important to create more than one load case for such a irregular construction. Okay, so then we turn to the next model in our wind. Yeah, those are silos. Yeah, imagine the bigger silos are already there, and you have to calculate such smaller silos with a support construction, maybe made of steel, and you have to calculate that construction and design it. And yeah, I would like to show you that this is important where the new silo is. If you have to place it here in your project, then in my eyes it's clear that there are higher wind pressure and suction as for this freestanding silo. But what about this place here? We would like to investigate that. And that it's much more easy in our Rfem. Let's turn to Rfem, to the calculated model. So that's the wind pressure and suction, the streamlines, but we would like to take a look at the static analysis for that wind load case. And I switched on only the PZ nodal supports. Okay. And you just compare the values for the support reactions here. For the freestanding silo, about 26. But for that silo, behind the bigger silos, 31, 32. But what is interesting is that the highest value is here on that silo, on that column, yeah, under that column, 39. Yeah, you can see it's really important to consider neighbor objects when neighbor objects are where, at least. Okay, then we turn back to our RWIND. So, that's a solar tracker. This is a high-rise building. Now you can see the streamlines. We can do a flow animation. Yeah, and you can see for that roof here, there are higher wind loads because of such a chimney effect. Yeah? Let's turn to the surface pressure. Yeah, you can see because of this chimney effect, there are higher values on the edge of that roof here. Then the next model, city, that's a whole city. That's also important maybe for architects when they plan to build a new building. Also, you need to consider the neighbor objects. Also, here will be a tunnel effect with higher values for dead buildings here. Or when you would change the wind direction in such a direction here, you can see for that building where is like a funnel here, and you would also have higher wind pressure, I can imagine at least. Okay, that should be all for these examples. I showed you the advantages of the CFD wind tunnel. I showed you customer projects here in RWIND and Rfem. And you can see it's quite important to do such wind simulations, at least for such objects that haven't a regular structure, but there are neighbor objects when we are different terrains, higher and lower terrains in your surrounding and so on. Okay, at the end of the webinar, I would like to show you our website. Quite new on our website is the community. You can communicate with us, with other users. You can ask questions and they will be answered by our experts or other users. You can get the newest information and so on. Okay. I would like to say thank you for your attention. Thanks to Clemens for answering the questions. I wish all a nice rest of the day. Bye-bye.